Welcome back. In this lecture, we'll continue our discussion on the stock market analysis project, and we'll try to see if there is any correlation between our stocks. In the previous lecture, we made a data frame from our adjusted close amount, right? And we saved this in a variable called stocks, and this is what our stocks data frame looks like. We have the adjusted close amount for each of the stocks, and then what we did was we calculated the return price and then transform our stocks data frame into this data frame, which is the stock return data frame, and we considered the return price. We calculated the return price and transformed it into this stock return data frame. So what we'll do is we'll take this stock return data frame and try to see if there is any correlation between our stocks. For that, we'll be plotting it by using methods like joint plot, pair plot, scatter plot, and so on. So first thing I will do is check out stock return data frame. So we have stock return dot head. Okay, this is what it looks like. First, let's try to plot a joint plot and see if there is any correlation. Let's consider the stock Google. So we'll use Seaborn's joint plot method. Okay, so we have SNS dot joint plot. So if you haven't imported Seaborn, make sure to import Seaborn. We did that in the beginning of the project. Import Seaborn as SNS. So SNS.joint plot, and we'll consider Google and then draw a joint plot against Google. So I'll show you what a positive correlation looks like. Okay, and then we'll pass the stock return data frame. Stock return, and for kind we'll pass scatter, and for color let's use red, or you can leave it to the default blue color. So if we run this, so this is a joint plot for our Google plot, for our Google stock against itself. Okay, this is what a positive correlation looks like. It has a Pearson R value of 1. So positive correlation values will be close to 0, and negative correlation, the line will look the reverse of this. The Pearson value will be close to negative, the Pearson R value will be close to -1. Okay, and the values can range between 0 and 1. Okay, for instance, if the value is 0.5, we can say there is some correlation. So by comparing the Pearson R value, we can say there is a relative correlation between, two given stocks. A stock is positively correlated to itself. You see, 100% correlation. So I wanted to show you this example. Similarly, if you take any other stock and draw a joint plot against itself, you'll see 100% correlation, because you are comparing a stock to itself. So that means whenever it goes up, since you are considering the same stock, it goes up. Whenever it goes down, the price goes down, and so on. That's why there is 100% correlation. If you take Starbucks, for instance, and change the color to green and run it, Pearson R value of 1. So this is what a positive correlation or 100% correlation looks like. Okay, next what we'll do is we'll plot a joint plot and consider two different stocks. For instance, let's see our two stocks, Google and Starbucks, and see if there is any correlation between them. So SNS.joint plot, We'll take Google and Starbucks. We'll consider our stack return, data frame, kind is scatter, and color is red. So this is what it looks like. You see here the %r value is negative 0.16. So they are not much correlated because the value is small value. Even if it's a negative value for the %r, it's still a low value. Okay. Next, let's consider two other stacks. Maybe Google and Apple, and see if there is any correlation between those two stacks. And let's check out blue color. Okay, here you see the %r value is 0.71. There is some strong correlation. You can see that from the plot here, from the scatter plots, or even by looking at the %r value, right? So this value is close to 1, 0.71. That's why you see some positive correlation between those two stacks, Apple and Google. Okay, let's consider some other stacks. For instance, let's see if there is any correlation between ExxonMobil and Starbucks. Let's run this. So you see here that %r value is negative 0.46. So they are more negatively correlated, right? The opposite of this. So they are more negatively correlated. That's by looking at the %r value. Let's see two more stacks. Let's consider Walmart and Starbucks maybe. Okay. Let's use green color. Okay, so and Starbucks and Walmart look to be negatively correlated, right? The %r value is negative 0.63. They seem to be negatively correlated. So that's what we can tell about correlation between any two given stacks by looking at the joint plot. And you can compare any of those 5 stacks or any stacks that you have. Next, let's see if we can tell any correlation by considering pair plots. Okay, so do you think we'll be able to get information regarding correlation by considering pair plots? Let's find out. So we'll call the pair plot method. Seaborn has a pair plot method, and then we'll pass our stack return, stack return, and then we'll call the drop NA method so that all the NAs will be dropped. Now let's run this and see what our pair plot looks like. So it might take a few seconds. Okay, now we have our pair plot of all the 5 stacks: Apple, Google, Starbucks, Walmart, and ExxonMobil. And the diagonals are histograms. They show the pair plot of a stack to itself. Okay, so here we have Apple. The first row value here is Apple, and here you have Walmart compared to itself, ExxonMobil compared to itself. Okay, that's what these histograms are, the diagonals. Okay, and so we can also grab some information about the correlation between any two given stacks. For instance, if I look at this figure here, it's for Starbucks versus Walmart, right? They seem to be negatively correlated. Starbucks versus Walmart, there seems to be some negative correlation, whereas if I consider the scatter plot, that's for ExxonMobil versus Walmart, there seem to be some positive correlation, right? Especially this part of the scatter plot. Whereas if I consider this plot, the scatter plot between Apple and ExxonMobil, we can't tell much if there is any correlation between those two stacks, right? And same thing here. I can't tell much whether there is any correlation between Google and ExxonMobil. Here I see some correlation, especially the scatters. This data sets, there seems to be some positive correlation between Walmart and ExxonMobil, whereas this part looks like there is some negative correlation, right? And here I can say that there is a negative correlation between Starbucks and, if I scroll down here, between Starbucks and Walmart. And there looks to be a positive correlation between Apple and Google. So that's what we can tell from our pair plot. By looking at our pair plots, we can get information regarding correlation among different stocks. Great. Let's consider one more plot. How about pair grids? Can we grab some information from pair grids? Let's find out. So we'll call the pair grid method that SNS.Seaborn has. So SNS.pairGrid, and we'll pass our stack return data frame, and then we'll drop any no values by calling the drop NA method. Okay, let's run the sensing. Again, it might take a few seconds. Okay, the information is empty. Let's pass some other attributes. Let's save this in a variable called stack return maybe figure, or you can save it anywhere that you like. And then what we'll do is call the map upper, map lower, and map diagonal on our stack return figure object, and then that will give us the visual for our pair grid. Okay, so let's take our stack return figure object and then call the map upper method, map upper, and then pass whatever you want to see on the upper part of the pair grid. Let's say we want to see scatter plots, so we'll call the scatter method, and for color, pass any color that you want. Let's try blue, and then next we'll call the map lower or map diagonal method on our stack return figure object. So stack return figure dot map lower, and then we'll call whatever plot you want to see. Let's say KDE plot, and then you can pass some color map. Let's pass RGBU, and finally we have our map diagonal method, so we'll call that on our stack return figure object, map diagonal, and whatever you want to see, pass it. So plt dot, let's say we want to see histogram for our map diagonal, so plt dot hist, and number of bins, let's pass 23. Run it. Okay, we got an error. It says module has no attribute KDE plot and our color map RDBU. Oh, this one, let me change it to RDBU, and then the other error we got is KDE plot is not in the module, so I'll change this to SNS.KDE plot. Let's run this again. It will take a few seconds. Great, now we have our pair grid, right? Again, the diagonals represent the stack against itself, which is the map diagonal method, and then for the lower part, right below the diagonal, we have our KDE plot, and then above the diagonal we call the scatter method, so we have the scatter plots. And again, you can see, that there is some correlation here between Apple and I believe it's Google. Yep. And some negative correlation here between Starbucks and Walmart here. And you have your KDE plots at the bottom, your scatter plots on top, and your diagonal is a histogram with 25 bits. Okay, you can still get information regarding correlation from pair grids. Okay, that's information about correlation using pair grids, joint plots, and pair plots. And again, we use the stack return data frame that we created, and that's by considering the return price from our stacks data frame. And as an exercise for you or more practice, what I will say is take your stacks data frame. So here we took our stacks data frame and then we used this apply method to transform it into this new data frame, which we called stack return. And for an exercise, what I will suggest is take the stacks data frame and then calculate the percentage change on it just by calling the percentage change method, and then save that in a new variable for your data frame and calculate what we did here. Okay, to give you an example, we have our stacks data frame, right? If we call our head method, we have this, the adjusted close amount for our stacks, and we can calculate the percentage change on our stacks data frame. So simply call the percentage change on it, the percentage change method, and we can save this in a new variable. Let's call it return underscore percentage, or save it wherever you want, return percentage. And then if you call the head method on it, we have a new data frame with the return percentage for each of the stacks, right? And then you can take this return percentage data frame and then plot what we did in this lecture. Joint plot, pair plot, whichever you want. For instance, if I want to plot a pair plot for this return percentage data frame, we can simply do that by calling Seaborn's pair plot method, and then we will pass our return percentage data frame and then apply the drop NA method on it. So all the NA values will be dropped. Okay, and then run it. So it will take a few seconds, and then here you have your pair plot for the stacks, right? And you can tell if there is any correlation for the return percentage. Okay, here you see there is some correlation between Starbucks and Google here, right? I see some correlation here also between Google and Starbucks. So plot a joint plot also, and then consider a stack to itself. That will give you a positive correlation, 100% correlation, which is what we did here. And then consider two different stacks and see if there is any correlation between those two stacks by looking at the Pearson R value and also how the scatter plot looks like. So you can try that out for yourself. That will be good practice and more exercise for you. Great. Thank you, everyone. And in the next lecture, we look at the moving averages for certain dates like 20 days, 100 days, and so on. Thank you, everyone.